Welcome to the Chemistry Notes, Part 3. Again, in the first couple parts, we talked about the periodic table, we talked about the elements. We were also able to start taking a look at how you find the protons, the neutrons, the electrons, the atomic mass, the atomic number when you're looking at a periodic table. Now, this focus in the Chemistry Notes, Part 3, we're going to take a look at the electrons, and we're going to take a look at elements, and we're going to take a look at how those electrons are arranged around each individual atom. Again, we're going to keep these notes short and simple so you don't have to sit down for an hour or two just to take one set of notes, but we're going to try and keep this under 10 minutes. So the electrons are arranged around a nucleus. Obviously, we know that they're in the electron cloud, where inside the nucleus you got the protons and the neutrons. Now, the electrons here are arranged in shells around the nucleus. Now, the word shells you'll hear quite a bit, but if you hear something such as an orbital or an energy level, a shell is sometimes called an orbital or energy level. They mean the same thing. So shells, orbitals, energy levels. Even in here in class, I'll try and call them shells whenever I can, but every once in a while, if I say, well, the energy level or the orbital, or if you're reading a textbook or a magazine on a science article, especially with chemistry, if you see those words, they all mean the same thing. Now, electrons are always moving. They spin very quickly around a nucleus. As the electron spins, they can move in any direction. They can go up, they can go down, they can go sideways, as long as they stay in their shells. Now, one might think it's just one shell, where they're all in one shell. But electrons can all have multiple shells. And scientists use letters to name the orbitals around the nucleus. And they use pretty simple, which is pretty simple. And they use simple letters. K, L, M, N, O, P, and Q. And right now, that's all we have. So, a common question I have is, first of all, why do they start with K? I'm not sure. They just did start with K. I'm sure there's a logical reason for it somewhere. I'm just not familiar with it. Another common question is, do we have to stop with Q? Well, right now, all the elements that have been discovered all will stop with Q. Now, do they all have to have a Q? No. For example, hydrogen and helium only have one shell. So if they only have one shell, they have the K shell. We'll get more into that in a little bit. So the K shell is actually the one closest to the nucleus, and the Q shell is the shell furthest away from the nucleus. Now, not all shells hold the same number of electrons. For the first 20 elements, there are some rules. First of all, the K shell can only hold up to 2 electrons. So does it have to have 2 electrons? No. Hydrogen only has 1 electron, so it's only going to have 1 electron in the K shell. Whereas helium has 2 electrons, so it'll have 2 in the K shell. Now, the L shell only holds 8 electrons. Now, the M shell only holds 8 electrons. And again, the M shell is the third shell. The M shell only holds 8 electrons for the first 20 elements. After that, it can actually hold more. It can actually hold up to 18, but it's not as simple, and we'll get more into that a little bit further into our notes. So that here it says just what I told you. The M shell can actually hold up to 18 electrons as you move further away along the periodic table. So here we see a picture or diagram where you have the nucleus in the middle, then you have the K, the L, the M, the N, the O, the P, the Q. So for example, if I showed you this picture and I asked you first, what is the element? Well, by looking over here, let me get an ink color. By looking over here, you see that it's Be. That should tell you it's beryllium. How many electrons does it have? Well, if the atomic number right here is 4, that should tell you that it has 4 electrons. And lo and behold, if we look out here, here's 1, here's 2, here's 3, and here's the 4th electron. It also have 4 protons. This right here would represent your nucleus. So you notice here's the K shell. It's kind of hard to see. Let me go to a different color. this color. So it's kind of hard to see right here. And let me go with a little bit wider. So it's kind of hard to see right here, but this was your K. You can kind of see it right here. Here's your L. Oops, sorry about that. And here's your M. So the first shell can only hold 2. So it had 1, it had 2 electrons. Now the next one can actually hold up to 8 more. But there's only 2 more electrons available. So that's all it filled up. Now here's a question for you. How many valence electrons does beryllium have? Well, if we look at here, it has 2 in the outer shell. So it would only have 2 valence electrons. Take a look at this model. This is actually the Bohr model. The Bohr model, you can see here in the middle, tells you protons, 79. And if we were to count each and every one of these small circles with the minus signs in them, that means, or it has a negative sign in it, those are the electrons. If you count them all, there'd be 79. And it has, right here, 118 neutrons. So again, this is your nucleus. So it's got 2 in the first shell. Here's your K shell. The next shell, which is your L, I'm going to go to a color that maybe might be a little bit more visible. Let's try red again. So here's your K, L, M, N, O, and P. So what were some of the rules? The K can only hold up to 2. So how many are in there? 2. The L can hold up to 8. Now, the M shell for the first 18 elements can only hold 8, but it can actually hold up to 18. So if we take a look at it, 2, 4, 6, 8, 10, 12, 14, 16, it has 18. Now you might say, well, what are the rules after here? Well, after here, it's not as easy. For example, it's not going to necessarily fill up the entire N before it goes to the O. In fact, it might actually put 1 in the N, 1 in the O, 1 in the P, and then it'll come back and put a few in this one, a few in this one. And there are some rules for that, and you'll get more into that in high school, all the different rules. But for our practical purposes, we're actually going to end right here. I'm not going to have you memorize these. All I'm going to have, anything outside the M shell. In fact, I'm only going to have you be responsible for anything up until things with the atomic number 18. So that's as far as I'd expect you to go here in class this year. Now the Lewis dot diagrams, you're going to have to be able to do this on the test. And each dot diagram consists of an elemental symbol and a group of 1 to 8 dots which show the configuration of the outermost electron shells. So again, when we look at this right here, outermost. And once we see outermost, that should tell you that those are the valence electrons. And I have that term right here. So anytime you hear the word outermost electrons, think of the valence electrons or the valence shell. So here's your Lewis dot diagram. What did it consist of? An elemental symbol. Oh, what's that the symbol for? Oxygen. Now, if we looked up at the periodic table, you would see that oxygen has an atomic number of 8. And if we looked at the shells, it'd have 2 in the K shell, because then it's full. And the L shell, well, if it had 8, there's 6 left. And look at this. 1, 2, 3, 4, 5, 6. Wow, it's the same. And that's why learning about valence electrons is important when it comes to Lewis dot diagram. And in part 4, we're going to learn why this is so handy. And we'll explain a little bit more. I'll tell you why it's handy. It's handy to have things in a Lewis dot structure when it comes to bonding, whether it's ionic or covalent, because then you'll be able to tell what it can easily bond with. Now the Bohr model, if you've already seen a Bohr model, you're going to have to do one of these on a test as well as the Lewis dot diagram. In the middle, you just have how many protons, how many neutrons, and then you put things in a shell. Again, here's your K shell, here's your L. You need to know that the K can hold up to 2. Wow, 1, 2. The L can hold up to 8, but here there's only 6, and this is oxygen again. I know it's oxygen because it has 6 electrons in the outer shell, 2 here in the inner shell, so 6 and 2 is 8, which matches the atomic number right here. And I know that also equals the number of protons. They're all equal, so oxygen is number 8. Now the Lewis dot diagram. Here's a nice simple way to do it. Again, you have your elemental symbol. So if it has 1 valence electrons, just put a dot right there. If it's got 2, you notice here's barium. It's got 2 valence electrons, so they put it in the 1 spot, and they put it in the 2 spot. And they just go around 1, 2, 3, 4, and then they go around again 5, 6, 7, 8. So it's a nice, good system. So here's your 1, 2, 3. It's a nice, good system to figure out where to put these dots around it. Now, you can never have more than 8. There's never more than 8 valence electrons, no matter how high up in the periodic table you go. So again, here's an example. You got lithium. Notice it has just the 1 valence electron. Notice it has more. So the Bohr model has all the electrons. The Lewis dot structure only has the outermost. So because there's only 1 in the outer shell, it only has 1. Looky here. There's 2 right here, 2 right here, 1, and 1. So how many are there? 6. So if you count the ones in this outer shell, there's only going to be 6. 2, 4, 6. And that finishes up part 3 of the notes. So hopefully by the time you finish these notes, you understand how to draw a Lewis dot structure, how to draw a Bohr model. You're going to have to do both of those on the test. And we'll talk more in this next set of notes, chemistry notes, part 4, about why the Lewis dot structure is really good to know and it's handy to know. So if you have any questions, just ask your science teacher. Goodbye.